I kind of did it the harder way in the notes, but if you look at the f of g of 4, so the first instruction I gave you guys was to rewrite it. Correct? And so that means is take 4 and plug it into the g of x equation. So let's do that. Now at this point you could probably go in and be like, what's 4 squared? So what's 4 times 4? 16 times 2, 32 minus 1, 31. So we have f of 31. Which means now we take that 31 and we plug it into where? F of x. So we triple 31, which gives you what? What's 3 times 31? 93 plus 2. And there's your answer. So let's look at B. G of f of 2. Well, look at f of 2. What's 3 times 2? 6 plus 2 is? So we're actually looking at g of 8. Plug it in for x in the g equation. So what is 8 squared? 64 times 2. 128 minus 1. It's the process of plugging something and getting in a result. So it's input output. There's a graphic that's on your notes, guys, before we started this, talking about input outputs. So the idea, guys, and I think it goes back when I was talking about functions. It's like a vending machine. If I input the code, I get that certain product out, correct? But now we're talking about composite of functions, which means this. If I put in a certain code, I get a product out. But then that product now goes back in and gives me another product out. So I know that sounds kind of not realistic, but that's the process we're doing here, is now it's one input takes you through 2 different functions. Okay? And as you did on the graph, guys, you were looking at the output, which is the y value, and that's how you got along the first section was, if we go back up to it, which I don't have it on my screen, but you look at the x value where x equals -1, go to the g of x. You get -1. Then you go -1 along the x value again, and you look where f of x, and you get 7. Well, your answer is 7, because the output of one is the input of the other. All right, let's go ahead and just get started on the example for find the domain of the composite function. So with this, guys, as we did in the example, what is the domain of the individual functions at first? So what x value can we not use in the function f? X cannot equal -3. What x value can we not use in the function g? X cannot equal 0. So far, guys, our domain is x is an element of all real numbers except x cannot equal 0 or -3. And now let's get that final puzzle piece to get this done, which is let's combine them together. So it looks like f of g of x. G of x is 2 over x. And now we rewrite the function f. Instead of putting x in the function, we're going to put what's in the parentheses. 1 over 2 over x plus 3. And here we're combining 2 fractions, right? Whoops. Got dyslexic there. Right? So you go here and say, okay, 2 times 1 is what, guys? Plus x times 3 is over x times 1. What do we do here? There you go. Or what we just established earlier. Just flip, right? How do I determine what the domain of this function is? Good. Good, guys. There's the last puzzle piece. That's the last part of our domain that we're missing. And therefore, now it's complete. You found the domain of the both individual fractions, both individual functions. You've composited them together, simplified, and found out what the domain is of your resulted composite function. All right? Let's look at, and I'm not going to do all of these, but let's just look at number 1. What's the domain of this? What x values can we not use here? We can use any, can't we? You're saying -1, guys, because you're setting equal to 0 and solving, but remember, that's only if it has a denominator. Is this x plus 1 a denominator of a fraction? Is it irrational? No, it's not. It's just a linear function. That's it. And that means it's all real numbers, isn't it? So, what about a quadratic? What's the domain of a quadratic? We've got to be careful sometimes here, right? Well, what values can I not square? I guess we don't need to be careful at all, do we? Can I square negative numbers? Can I square 0? Can I square positive numbers? All real numbers. Then I'll have you composite it, guys, and see what the domain is, what's left over, okay? I'll let you know it's all real numbers. There you go. But I want to see the equation. All right, number 2. What's the problem with number 2 that we have to check? The square root. What has to be true about functions of square roots? They must always, what's underneath the square root must always be positive. Can it equal 0? Can we take the square root of 0? Yes, we can. Square root of 0 is 0. So here's what I'm going to do. I'm going to take what's inside x minus 2, and I'm going to say that needs to be greater than or equal to 0. And solve. So, x is greater than or equal to 2. That means any value that's greater than or any number that's greater than or equal to 2 will work in that equation. What about g of x? What's the domain there? Because it's a linear function, right? All right, let's do this one. Let's do this one together. What are we compositing? Does it even say? Well, it's probably going to be f of g of x. So it's f of g of x. So it's f of 1 minus 2 times x. Plug it into the other equation, so you get square root of 1 minus 2x minus 2x. Nope. I didn't do that right, did I? Sorry, guys. It is 1 minus 2x minus 2, right? Didn't need the extra x there. All right, so let's keep going with this. Simplify this. It's just a lot of negative stuff over a square root. But what do we know we need to do here, guys? Well, first off, can we simplify this anymore? Is there any other like terms I can combine together? No. Is there anything I can take a square root of? No. So we need to go ahead and figure out, this is my result. This is the composite function here. So now what we need to do is say, okay, with this being the composite function, how do I find out its domain? What x values can I not use? How do I find that? Johnny? This right here. This function right here has to be the negative 1 minus 2x has to be greater than or equal to 0. So we solve. And of course, when you divide by a negative 2, what do you have to do to the inequality symbol? You got to flip it. So, only when you're dividing by a negative is when you flip it. Okay, so here's what we have, guys. If I was to look at a number line, which I'm going to kind of cheat over here. For my original problem, I have x is greater than 2. So that's all the way out to infinity. For the other side, when I did a composite, I started at negative 1/2, and I said it's less than that. Guys, all those values give me positive answers, give me answers, correct? We said every single one of those equations greater than or equal to 0. Do you all agree? Which means if those equations were greater than or equal to 0, would I get an answer? Can I take the square root? Yes. So guys, where does it not work? Right there. Right there, this function will not work. So, I go through and say, my domain is an interval. Negative 1/2 to 2, including the endpoints.